So that leads us to the last way we can get rid of heat, which is evaporation. The basic idea is we have our skin, we sweat or spray water on it, so we get a thin layer of water on some fraction of the surface. Some of this water evaporates, and when it evaporates it carries away a huge amount of energy. Remember that the latent heat of vaporization for water is about 2.3 by 10 to the 6 joules per kilogram. So that's over 2 million joules carried away if you can evaporate 1 litre of water from your surface. So in principle this is an incredibly efficient way of getting rid of surplus heat. So is that how you could have super fast, super powerful beings, just have them constantly wet and sweaty all over the surface? Well, the limitation is probably going to be how much sweat can actually evaporate. Now this is a very hard thing to calculate. I tried to come up with a simple way to calculate it and it's just not easy. It depends on too many things. It depends on the humidity of the air, the velocity of the air, the temperature in complicated ways. You can find some equations for this on the web, but none of them are very good. The best way to measure this one is experimental. And luckily meteorologists for over 100 years have been putting out pans of water and measuring how rapidly the water goes down in different parts of the world. So for example in Canberra in summer a pan of water will go down by about 200 millimeters per month. In the outback in summer it can be around 400 millimeters per month. How about somewhere more humid, somewhere like Singapore or Hong Kong or far north Queensland? In summer, Singapore, you're getting about 100 millimeters per month. It's hot there, though not as hot as the outback in midsummer, but it's humid, which stops the evaporation being too high. On the other extreme, you can get places like Siberia or northern Canada, where the evaporation rates in midwinter might only be 1 or 2 millimeters per month, but then keeping cool in those places is not really a problem. So how much heat can you lose off your body? So now 1 millimeter per month over 1 square meter is a volume that's 1 millimeter by a meter by a meter. So that's 10 to the minus 3 cubic meters times the density of water, which is about 1,000 kilograms per cubic meter. So it comes out as about 1 kilogram per meter squared per month. If you divide by the number of seconds as a month, that comes out as about 4 by 10 to the minus 7 kilograms per meter squared per second. So if we're going for a run in Canberra in summer, evaporation rate will be about 8 times 10 to the minus 5 kilograms per meter squared per second. That's just multiplying this by the 200 millimeters per month. So how much heat can we lose? Let's assume we've got 2 square meters of surface area. So you multiply by 2 and you multiply by the latent heat, 2.3 by 10 to the 6 joules per kilogram, and that comes out as you're losing about 0.6 liters per hour, which is about 368 watts, so ballpark 400 watts. So in somewhere like Canberra, this is the most effective way of getting rid of heat. If the surface of your body was entirely covered with sweat and it's evaporating away at the typical rate for Canberra in summer, that's carrying away as much energy as you could do, even being incredibly energetic. Which is an interesting coincidence. That kind of sounds like it might be the limiting factor then. If it's cold and dry, you can lose a lot more. If, on the other hand, it's a very humid place like Singapore, then you're only going to be able to get rid of maybe half of that or even less. So this works if you're in a dry place like Canberra, not so good in humid places, but it's still the biggest source of energy loss.